Hi, my name's Dave. I'm a product manager here at Google, and I'm really excited to be here today. So today, Jeff, Archit, and I are going to show you how transactions work on the Google Assistant. So we were super excited to launch Actions on Google last December, opening the door for developers like you to create great experiences for the Google Assistant. However, there were a couple of gaps. So first, Actions on Google only worked on the Google Home. So as we announced this week, that's changed. Actions on Google is now available on phones, and now any developer can build great multimodal experiences for the Google Assistant. Second, Actions on Google didn't support transactions, and that's what we're here to discuss today. Let's see one in action. Order delivery from Panera.
Hi, this is Panera. For delivery, I'll just need the address. Which one can I get from Google? What can I get you started with?
Need something with bacon in it?
Got it. How about one of these cold drinks?
Power smoothie.
Great. Are you ready to check out?
Yes.
Here's your order summary. Your total is $17.74. Ready to place the order?
Yes.
Thanks. You're all set. By the way, I can sign you up today for a My Panera account. Are you interested?
I heard they give you free pastries with every account creation, so yes. One more tap to create my account.
Congrats, you're now our newest member. See you next time.
And look, I already have a notification from Panera. Thanks. And they're super quick, so my delivery is going to arrive in just 20 minutes. I tap into that. And look, here's my full receipt with some follow-up actions on the bottom. Pretty cool, right? So let's review what just happened. I was a customer who never interacted with Panera before. I was able to share my payment and my address with a single tap. I created a new Panera account with just 2 taps. Panera updated me on the status of my order via a notification. And finally, I was able to pull up all of the details of the order, including follow-up actions, from my Assistant order history. So let's back up. The way that users interact with technology is fundamentally changing. This has been the theme for the past year with Google Assistant. So we're in the middle of a shift from web to app to assistants. So from clicks to swipes to voice. And good assistants, human assistants, are useful for a number of reasons. They know who you are. They know your payment information. They know your friends and your contacts. They know your preferences, like if you like skim milk in your coffee or if you like the aisle seat on the airline. They're always with you. They're accessible 24 hours a day from your home, in your car, in your living room, when you're out and about. And they're easy to use. You just talk to them, and they do all of the hard work. But assistants can't do everything. They can't make you pizzas. They can't drive you to the airport. A real assistant has more than just information. They help you get things done in the real world. And the Google Assistant needs an ecosystem of partners to help us do that. Good ecosystems need 3 things to be successful. So over the long term, users are only going to use the Google Assistant if it's powerful, if it's actually the easiest way to get things done. It can't just be a novelty. And over the long term, developers are only going to invest in building apps for the Google Assistant if there's a return on that investment. You have to be able to monetize it. So to create this virtuous cycle, Assistant really needs to provide value to both users and developers. One way we're addressing this is with distribution. We're bringing Assistant and Actions on Google to lots of users and services, starting with Google Home back in December. Now it's available on Android and iOS. And in the future, we're going to support Android TV, Allo, Wear, Auto, and even non-Google devices via the Assistant SDK. Assistant's built into a drink mixing machine right outside. So we're going to have the audience, hundreds of millions of users. How do transactions fit in? So first, what are transactions in a Google Assistant context? They could be purchases, like food delivery or concert tickets, or they could be reservations and appointments. So for example, a haircut, a restaurant, or a yoga class. And why do transactions matter to our ecosystem? One, it's good for users. It bridges the gap between information and action, between the assistant knowing things and the assistant doing things. It helps users in the real world, and it makes their lives easier. It's also good for developers. You can find new users, you can re-engage existing users, and more importantly, you can monetize your actions on Google App. So, if transactions are good for everybody, what's the problem? Simple. Buying stuff can be really hard, right? There's a lot of friction. There's a lot of places for people to drop off. And two of the biggest pain points are with payments and identity. So let's say you're in real life. You go to the store, take an item off the shelf, you go to the cashier, and you pay for it. So it's pretty simple. It's just not very convenient. What if what you wanted was sold out? Or how did you know what was on sale before you got there? What if what you want is cheaper somewhere else? With apps, you have to download the app. You enter your payment information and your personal details like your address and your phone. And then finally, you build your cart and you pay. OK, it's not too bad. But this gets really old if you have to do this for every single app. And worse, every time you switch a device, you have to download the app again, and then you have to sign in again. On top of that, a lot of assistant transactions today require all of that, and you also have to create an account with the app, and then link that account to the assistant. And then finally, you can pay. It's just not really that easy. So Google already has users' payment and identity information. And like a human assistant, Google Assistant can facilitate transactions on the user's behalf by passing that information to you. So less friction means more purchases. It's happier users and happier developers. So let's recap. Transactions on Actions on Google has 3 major platform features. We already talked about the first 2, which are payments and identity. The third is re-engagement, which we'll discuss in a little bit. These features are implemented independently. You don't need to implement Google facilitated payments to get streamlined identity and vice versa. But good flows really do incorporate all 3. Let's go into a bit more detail, starting with payments. Did you know up to a third of users are going to abandon a checkout flow if they have to enter a credit card? So here's the thing. Anyone who's ever purchased an Android app or rented a movie from Google Play already has a card on file with Google. Users have already saved hundreds of millions of debit and credit cards to their Google accounts. And Google can securely pass that payment information to you during an assistant transaction. Here's how it works. First, you tell Google you need to charge a certain amount to a certain user. Google then encrypts the raw credit card information with your payment processor's key. And this is specific to you. And then it generates an encrypted payment credential. Google then passes you that credential, and then you charge it like you would any normal debit or credit card. That's it. Google facilitated payments are convenient. For users, it's a single tap to pay. It's free. Google doesn't charge a fee for this. You just pay the standard processing fees to your payment processor. And it's lightweight. You just indicate at runtime that you need a payment credential, and we'll figure it out. You charge it like you would a normal credit card. These are the payment processors we support today, and we have more coming online in the next several months. And of course, using Google facilitated payments is completely optional. If your customers already have a payment method with you, for example, loyalty card or points, you can use that too. So that said, let's talk about the second platform feature, seamless identity. So half of all users are going to abandon a flow if they have to create a new account. And up to 90% of users will leave, abandon the flow altogether if they forget their password or login information. So imagine you're interacting with a user on the assistant, and you'd like the user to either sign in or create a new account. There's a really good chance you're going to lose that user. Over half of users are going to drop out at this point. And this gets even worse if the user has to switch devices. So for example, a Google Home user has to enter their username and password on a phone. But since every Google Assistant user has an identity defined with Google, Google can share that identity with you to create or link to an account on your system. These identity assertion flows make linking seamless. Just 2 taps and you're done. And this can even work in eyes-free, hands-free scenarios. So users can link to existing accounts or create new accounts with you without ever picking up their phone. Here's how it works. When the user taps their account chip in this modal, Google sends you an identity token. That token contains information such as the user's name and email address. You use the contents of that token to look up the user in your system. If they don't have an account with you yet, you can create one using the user's Google identity. This works similarly to Google Sign-In. If they do already have an account with you, you can optionally ask the user to accept additional OAuth 2 scopes to complete the account linking process. These assertion flows are easy to implement on top of existing OAuth 2 flows. So we've already gotten some really good feedback from our early access partners about this. With relatively incremental investment, you can minimize that huge drop-off on account linking and account creation. Let's move on to the third platform feature, re-engagement. Transactions don't stop when the user pays. Users may have questions about the order. So for example, where is it? What's the status of my return? Can I add something to the order before it ships? Or maybe they want to take action against it. They want to move the appointment, or maybe upgrade their seat to first class, or refill a prescription. Google Assistant maintains all of that transaction history in a single place. Makes it really easy for users to find an order and re-engage with it. Users can easily initiate these follow-up actions that you define for your orders, both from the transaction history or simply by asking the assistant. You can also reach back out to your customers by providing order updates, because users care when their Uber is arriving or if the salon needs to cancel the haircut. Users can stay up to date about their orders with you without having to download your app or search through their email. So that wraps up our overview of the main platform features. Now Jeff is going to walk us through how to integrate transactions into your app.
Well, we're super excited to be opening up the developer preview for Assistant Transactions this week. The Transactions API is part of the Actions on Google framework. So before we get into this new API, let's first start with a brief review of how you use Actions to build Assistant apps. For more detailed instructions on getting started with Assistant apps, go to developers.google.com/actions. And you can also check out yesterday's I/O talk on building apps for the Google Assistant, which is now available on YouTube. So an Assistant app is simply a set of webhook endpoints that receive a request from the assistant for each turn of a conversation with the user. So when a user talks to your app, the Google Assistant transcribes the user's input and sends it to your app as text. So you can use whatever web server and language you like for your webhook, though we like to use Node.js for its simplicity, and we also provide a client library to make it easier to work with the request and response formats. You can get the client library with an npm install actions on Google. So you work with the raw text input in your webhook, or you can use a natural language understanding tool, such as API AI, which will convert this text into a higher level parameterized user intent. So we'll use API AI and Node.js for all the examples in our talk today. So in the example here, the user would like to order a classic burger. API AI matches this to an add item intent and a classic burger entity that you would have already defined in the API AI tool, and then sends this along to your webhook as part of the JSON payload. So you can respond to the user in a number of ways, including a simple response, which takes the form of either a chat bubble or text-to-speech. Or you can also send rich responses, which, in addition to the simple response, can include other components, such as cards and lists or suggestion chips. So in this example, we're using the Node.js client library to build a card as the response. The card contains an image, some suggestion chips for the user, and other information. You typically respond with app.ask, which will open the mic to accept the user input for the next turn of the conversation. So that's simple and rich responses. The third type of response is to call a helper. So when you respond to an assistant request by invoking a helper, this tells the assistant to momentarily take over the conversation to obtain some specific information for your app. This is done in a standardized way, but still using the voice of your app. So for example, a helper could be used to get a confirmation from the user, meaning a yes or no response to a question, and then return this to your app. So you can think of this from your app's perspective as a two-step process. So you tell the assistant what information you need from the user, and then that information is then passed back to you on the next request. So it's these helpers that we use to handle the transactional part of your conversation with the user. So let's take a typical e-commerce scenario where you'll have one or more dialogue turns with the user to construct their basket of goods. So you might have a simple single item basket that you might be able to satisfy with a single dialogue turn, or maybe you have something more complicated like our food ordering example, where you can have lots of items and add-ons and adjustments. So you use a combination of these simple and rich responses, such as the carousel that we see here, to build this basket of goods with the user. Once this basket's established, then you'll use the transaction helpers to take the user through checkout. So there are 4 transaction helpers available. The first is ask for delivery address. So this gets a delivery address from the user, allowing them to select from their stored address book, and then it's sent back to you. The second is to propose or present the order to the user. So here you indicate to the user what it is that they're buying, and you receive their acceptance back on the next turn, often with their payment credentials. Next is the confirmation of the order step. So upon receiving the user's acceptance of the order from your app, you then confirm back to the user that you received it and it's a good order. As part of this turn, you'll also show a summary of the order to the user. And finally, Google account linking. So as Dave mentioned, this allows the user to sign in or create an account with your service using your OAuth 2 server. Or if you support the OAuth 2 assertion flows, users can sign in or create accounts using just a couple of taps. So this might be the typical e-commerce flow where the user first builds their basket of goods, picks a delivery address, and then they go through the checkout flow and can optionally create an account. But it could also be the case, for example, that you need an address first. For example, to determine inventory availability or pricing or service area. So you can certainly sequence the steps as needed for your use case. Or you could skip steps entirely. So for example, you might not have an OAuth 2 endpoint, or you're fine with a guest checkout flow. So you don't need to ask the user to sign in. And even with your best laid plans, the users manage to keep things interesting when you're building conversation apps. So for example, the user could decide to add something to the basket when they're at the checkout step, or maybe change their address. So in this case, you might need to modify or recalculate the order and then present it to the user again for their acceptance. So the transaction helpers can help handle these different responses from the user and send them back to your app as text or intents. The only 2 required steps in the flow are to propose the order so the user can see exactly what it is that they're purchasing. Then again, the assistant will collect the user's authorization for that order, and then to confirm the order with the user after it's been placed. You should also send updates about the order as it's fulfilled, and we'll talk more about that in a few minutes. So the basic data structure for every transaction is an order. Each order has a cart where you specify line items, sub-line items, and notes. And so for example, in our burger example, a hamburger might be a line item, and a bacon add-on would be a sub-line, and you might have medium rare in the notes. So item versus sub-item really only affects the presentation of the receipt that the user sees. So it's really your choice as to how you structure the cart in a way that the user can clearly understand what it is that they're purchasing. And then on the order itself, you'll set fees and other adjustments, total price, delivery address, and overall image for the order. So once you propose the order, once you present the order to the user and the user authorizes it, the assistant then sends the order back to your app with some additional data added to it. So this includes an initial status. So this will typically be the value created that we set. You'll also receive the payment method for this order if you're using a Google facilitated payment. We'll set a creation time on the order, as well as a Google-generated order ID. So those are the common flows and data structure that we use for transactions. So now that we have that, let's take a look at how this works in the code. So we first define a function. I'm going to define the function here that creates a cart and stores it in the app data session state. So to create our cart, we call app.buildCart and set some merchant metadata. Again, that's just going to appear in the receipt. Next, we define the structure of the cart through line items and sublines. So for this example, I've hard-coded items for the cart, but of course in a real app, you would determine the set of items over your dialog turns with the user. So here we're adding our burger with bacon and also specifying unique IDs, which are required for each item in the order, as well as price and quantity and other standard information. So now, if you require a delivery address, you'll call the ask for delivery address helper. When you call this, you should also provide some additional context for the user so they understand why they're giving their address to you. The user's response comes back as the delivery address complete intent in the subsequent request, which I've mapped to a function of the same name in this example. Here we check that the delivery address was sent back by the user, and if so, we store it in app.data. Then we'll ask the user if they're ready to check out, and then we'll check out on the next turn of the conversation. So if the user chose not to provide an address in this example, as you see in the else condition, we can prompt them again, possibly giving them an alternative, or maybe just an escape hatch, or ending the conversation. Great, so the user's given us an address, and they're ready to check out. So let's define a method to create our order. So first, we call app.buildOrder. We set the cart that we created and stored in our session previously. And then we set the image for the order. We add tax and other items for the order, and finally the total price. So now we have our cart and our order, and we're going to propose the order to the user, to present it to the user. So first, we define our payment configuration parameters. So in this case, I want Google to provide a payment instrument for the user. This is using Google facilitated payments. So as Dave talked about earlier, this allows the user to select their card on file with Google. So if I set this input to the proposed order method, the user will get a list of their credit cards that match the set of filter criteria that I set up. So here I'm specifying that I only support Visa and MasterCard, and I'm also setting the tokenization parameters specific to my payment processor. In this case, I'm using Stripe. Next, I call ask for transaction decision with this order and the payment configuration. The order is then presented to the user, as you see on the left, and the assistant handles all the details of collecting the user's response, getting the user's authorization for the purchase, and then passes all of the agreed upon order and payment information back to me. And if you don't want to use facilitated payments with this, you're also free to use your own app-provided payment instrument. So in this example, I'm simply describing the form of payment being used so that the user can actually see this in the receipt. And so, for example, we could set the last 4 digits of the payment instrument or loyalty program, and then this will be displayed for the user during checkout. And of course, this typically requires that you have the user signed in and they have a card on file with you already, so you know what to charge. So the benefit of this is that you still get to use the same checkout flow dialogues, user authorization, and other benefits, but you have the flexibility of using your own payment instruments if you choose. And finally, you can drop the payment config altogether, so you can have an order that doesn't require any payment at all. So if you have a reservation that has no cost, you can use that, but still get all the benefits of the checkout flow. Okay, so the order is presented by the assistant. It looks good to the user, and they authorize the transaction. The response is sent back to your app as part of the transaction decision complete intent. So here you get the user's decision, and if the user is accepted, then you'll likely call your backend to create or persist the order, and likely call your payment processor to authorize the card or charge the card. Finally, you need to send a response back to the user, again confirming that the order has been successfully received by your app, and you give them the current state of that order. So first, you obtain the Google Order ID, so we know which order you're confirming. Then you create the rich response. This time you create an order update object, which indicates initial state. You specify a final order ID if it's changed, and set some text to include in the response. This results in the final receipt confirmation presented to the user, as you see on the left, and then the conversation continues from there. On this last line with the else condition, we have an example of handling alternate user decisions. So here the user's chosen to change their address during checkout. So instead of course, being able to charge their card, we'll send this response back to you, and you have the option of creating a new order and presenting it to the user again. So this covers the order creation APIs. Now I'll hand off to Archita to talk about follow-up actions.
Now, let us talk about how Assistant facilitates the follow-up interactions between the app developers and the users after the conversation ends. After the order is placed, you should send order updates for all meaningful changes to the order. For example, a ride-sharing app might send updates when the car has arrived. A food delivery app might send updates when the food is delivered. A restaurant reservation app might send updates if the reservation is canceled. Important updates will trigger a notification to the user. All order updates are also visible in the order history. You can also attach follow-up actions to each order update. In a food delivery scenario, while the food is being prepared, you could have follow-up actions like track order, call restaurant, or cancel. After the food has been delivered, the follow-up actions could be rate restaurant and reorder. There are 4 types of follow-up actions. Email and phone are straightforward. You might use these for customer service contacts. URLs can be deep links to websites or apps. For example, you might want to link to a live tracker for a delivery or image of a QR code for concert tickets. Intents launch the user back into a conversation with your Assistant app. You specify the intent that should be triggered and pre-fill any arguments. For example, the order ID. Your Assistant app might let the users check your return policy, reschedule an appointment, or quickly reorder. Order updates are simply post requests to an Actions on Google endpoint. The following code snippet shows how to build an order update. First, populate the updated state along with required supporting information. In this example, the order is in transit. Next, set the content of the system notification, like your food shop order is on its way. Last, add any follow-up actions to the order update. These are displayed along with the receipt in the order history. In this example, we have added a follow-up action of type URL to contact the customer service. Finally, let's talk about account linking and account creation. First, register your OAuth 2 configuration in Actions on Google console. At runtime, check whether the user has already linked accounts. You can do so by verifying if an OAuth 2 access token is included in Assistant's request to your app. To start the account linking flow, simply call ask for sign-in helper method. What happens next depends on the configuration you defined and whether the user already has an account in your system. If you support OAuth assertion flows, we will send you a JSON web token. You can use the contents of this token to look up the user in your system. If they don't already have an account, create a new account and return the OAuth2 refresh token. If they already have an account, you may optionally ask the user to accept additional OAuth2 scopes to complete the account linking flow. If you don't support JWT assertion flow, we will trigger a standard OAuth2 account linking flow in a web browser. After the user signs in, return an OAuth2 refresh token. Now, back to Dave.
So we have a great set of early access partners already developing transactional apps for the Google Assistant. Soon, you'll be able to send flowers, or buy dinner, or order concert tickets. These are just some initial examples of how the Actions on Google ecosystem is extending the Google Assistant to help users in the real world and to bridge the gap between it knowing things and doing things. Transactions is currently in developer preview. You can start adding transactions into your Actions on Google apps today. Please visit the link here for more details about our APIs, documentation, and helper libraries. Actions on Google is also running a developer challenge with prizes including a trip to I/O 2018. The consumer experience is going to launch on phones soon and then expand to other surfaces such as home, wear, and more. We're really excited to see what you're going to build.